As vehicles become more electrified and increasingly automated, the complexity of their power systems grows dramatically. What was once a relatively simple low-voltage network is now responsible for supporting safety-critical systems like steering, braking, perception sensors, and dozens of electronic control units. In these environments, even small electrical interferences can have serious and potentially fatal consequences. For the BMW Group, this reality raised a critical question. How do you identify and mitigate these risks early in development before a vehicle ever reaches the road? BMW's answer was to shift the development of the vehicle's low-voltage power system into the virtual domain using a digital twin methodology. The goal was to detect critical failure scenarios during the concept phase, long before physical prototypes were built, and to derive countermeasures such as harness redesigns or component changes through simulation. At the center of this approach is a tightly coupled digital and physical twin. The digital twin acts as a virtual replica of the vehicle's power system, while the physical twin, a system-level validation test bench, anchors those simulations to reality using real-time measurements and sensor data. A key innovation in BMW's methodology is its focus on dynamic behavior. Modern vehicles must be fail-safe and fail-operational, especially in highly automated and fully automated driving scenarios. That means power systems must be stressed dynamically across wide frequency ranges to reveal weaknesses that static testing would never uncover. To achieve this, BMW developed highly accurate models for every component influencing the power system. This includes safety-critical systems like brakes and steering, as well as high-power loads such as fans and audio systems. These models were refined through road testing, where real electrical behavior was recorded and later replayed in the lab to validate accuracy. The backbone of this validation environment is NI's real-time PXI platform, which serves as the central test system for the physical twin. PXI's modular architecture enables high-accuracy measurements and high-speed signal processing, all while tightly integrating measurement, control, and simulation. Using tools like LabVIEW and VariStand, BMW built highly automated test sequences and integrated third-party software such as Vector Canoe. This automation delivered unprecedented repeatability and system-level validation, something that's essential when testing complex, safety-critical systems. The results of this combined digital-physical approach were significant. BMW can now detect defects much earlier in development, reducing both time and cost. Some system models now run 95% faster, while power system interferences in the 10 to 100 kHz range have been reduced by 75% through targeted countermeasures. The accuracy of the models is equally impressive, showing less than 5% deviation from real-world behavior up to 150 kHz. Looking ahead, BMW expects this approach to enable 20% faster development cycles, accelerating time to market without compromising safety. In many ways, BMW's digital twin now functions like a high-fidelity flight simulator for the vehicle's power system. Engineers can intentionally push the system to failure, analyze weaknesses, and apply fixes again and again without the cost and risk of building physical prototypes. By combining virtual simulation with real-time validation, BMW has transformed how vehicle power systems are designed, tested, and validated, setting a new standard for safety, efficiency, and innovation in modern automotive engineering. This concludes today's video. Thanks for watching. If you're looking for legacy NI parts, calibration services, or more technical resources, head on over to apexwaves.com to get what you need fast. We have thousands of NI parts in stock and ready to ship, including legacy and obsolete modules you won't find anywhere else. And if you found this helpful, don't forget to like this video and subscribe to our channel for more product highlights, how-tos, and industry insights.